Imagine you're taking a road trip through our solar system. If you start from the Sun, the second planet you would pass is Venus. It's our closest planetary neighbor, sometimes shining so brightly in our night sky that people mistake it for a star. They often call it the morning star or the evening star because you can see it just before sunrise or just after sunset. For a long time, people thought Venus might be a lot like Earth. It's about the same size, it's made of similar rocky materials, and it's right next door in our cosmic neighborhood. It seemed like a perfect candidate for a sister planet, a place where life might have a chance. But as we learned more, we discovered that Venus is hiding a very different personality. It's not a welcoming paradise, it's more like Earth's evil twin. Think about it. Venus is named after the Roman goddess of love and beauty, but its surface is one of the most hostile, dangerous places we have ever discovered. It's a world that shows us how planetary environments can go in very, very different directions. Exploring Venus teaches us about the delicate balance that makes a planet like Earth just right for life. It's a cautionary tale written in the language of physics and chemistry, showing what can happen when a planet's climate goes completely out of control. Even though it's farther from the Sun than Mercury, Venus is actually the hottest planet in our solar system. How can that be? It all comes down to its atmosphere. Venus has an incredibly thick blanket of clouds and gases that traps the Sun's heat. This is called a runaway greenhouse effect. It's like leaving a car parked in the sun on a summer day with all the windows rolled up but magnified thousands of times over. The heat gets in, but it can't get out. This effect has turned Venus into a planetary oven, a world with temperatures hot enough to melt lead. It's a powerful reminder of how important the planet's atmosphere is. So, while we might look up and see a beautiful, serene-looking point of light, we now know the truth. That tranquil dot is a world of extreme conditions. It spins backward compared to most other planets, so the sun rises in the west and sets in the east. A day on Venus is longer than its year. It takes Venus 243 Earth days to spin around just once, but only 225 Earth days to orbit the sun. It's a strange, slow-dancing, super-hot neighbor, and studying it helps us appreciate the very special conditions we have here on our own planet, Earth. It's science, and it's fascinating. Let's zoom in a little closer on what makes Venus so unwelcoming. The first thing you'd notice, if you could notice anything before being instantly destroyed, is the atmosphere. On Earth, our air is mostly nitrogen and oxygen, the very stuff we need to breathe. Venus's atmosphere is almost entirely carbon dioxide, a gas we breathe out. You couldn't take a single breath there. This thick, heavy blanket of carbon dioxide is the main reason the planet is so incredibly hot. It creates an intense greenhouse effect that has superheated the planet's surface to an average of about 465 degrees Celsius, or 870 degrees Fahrenheit. That's hotter than your home's oven set to its highest temperature. The atmosphere on Venus is not just unbreathable, it's also incredibly heavy. The atmospheric pressure on the surface of Venus is over 90 times greater than what we experience on Earth. Standing on Venus would feel like being almost a kilometer, about 3,000 feet deep in the ocean. The weight of the air itself would crush you. A person, a car, or even a spacecraft not built to withstand it would be flattened in an instant. This crushing pressure is one of the biggest challenges for sending probes to explore the Venusian surface. It's a powerful force of nature that makes survival there an extraordinary engineering problem. On top of the heat and pressure, there's the weather. The clouds on Venus aren't made of water like they are on Earth. Instead, they are made of droplets of sulfuric acid. That's right, the same kind of powerful acid you might find in a car battery. This means it rains sulfuric acid on Venus. However, because the surface is so intensely hot, the acid rain never actually reaches the ground. It evaporates in mid-air, creating a cycle of acid clouds and acid vapor. The planet is also covered in high-speed winds that whip around the globe, circling the entire planet in just 4 Earth days. So, let's recap the environment on our sister planet. You have a surface hot enough to melt lead, atmospheric pressure that can crush a submarine, an unbreathable air made of carbon dioxide, and clouds that rain down sulfuric acid. There are no blue skies, no gentle breezes, and no liquid water. The sky on Venus is a hazy, oppressive yellow-orange due to the way the thick atmosphere scatters sunlight. It's a dramatic and dangerous world, a perfect example of how different a planet can be, even when it's so close to our own. It's a place that pushes our understanding of planetary science to the absolute limit. When you compare Venus and Earth, it's like looking at two family portraits taken millions of years apart. where one sibling went down a very different path. On the surface, they seem so similar. Earth and Venus are both rocky, terrestrial planets, and they are nearly the same size and have similar mass. Scientists believe they were formed from the same cosmic dust and gas around the same time, about 4.5 billion years ago. For these reasons, Venus is often called Earth's sister planet. Early in their histories, Venus may have even been much more like Earth, with oceans of liquid water and a more temperate climate. The big difference, the fork in the cosmic road, was the atmosphere. Earth's atmosphere developed into a life-sustaining blend of nitrogen, oxygen, and a small balanced amount of greenhouse gases like carbon dioxide and water vapor. This balance keeps our planet warm enough for liquid water, but not so warm that the oceans boil away. It's a delicate thermostat that has allowed life to flourish for billions of years. We live within this thin, precious layer of air that protects us from the harshness of space, gives us oxygen to breathe, and creates the weather patterns we know. It's our planetary life support system. Venus, on the other hand, experienced a runaway greenhouse effect. Being a bit closer to the sun, it received more solar energy. This likely caused its early oceans to start evaporating. Water vapor is a potent greenhouse gas, so as more water entered the atmosphere, it trapped more heat, which caused the oceans to evaporate even faster. This vicious cycle continued, raising the temperature until all the water was gone and carbon dioxide, released from rocks by the intense heat, filled the atmosphere. Venus's thermostat broke, and the temperature soared, creating the scorching high-pressure world we see today. It became a permanent planet-wide heatwave. This comparison is incredibly important for us here on Earth. By studying why Venus became a scorching hothouse while Earth remained a habitable oasis, we can learn crucial lessons about our own climate. It highlights the importance of our atmosphere and the potential consequences of altering its composition. Venus serves as a stark warning, a real-life scientific model of what happens when greenhouse gases run amok on a planetary scale. Understanding Venus isn't just about exploring another world, it's also about understanding and protecting our own. It's a lesson in planetary stewardship, written across the solar system. So, given everything we know, could a human ever survive on Venus? If you were to step out onto the surface of Venus without any protection, the answer is a hard no. You wouldn't last for even a single second. Before you could even take a breath of the toxic air, the immense atmospheric pressure would instantly crush you. At the same time, the extreme heat, far hotter than any natural environment on Earth, would incinerate you. It would be a swift and certain end. The combination of pressure, heat, and corrosive atmosphere makes the surface of Venus one of the deadliest places in the solar system for an unprotected human. But what about with technology? Humans are incredible problem solvers. We've built submarines to explore the deep ocean and spacecraft to travel through the vacuum of space. To survive on the surface of Venus, you would need a suit or a habitat far more advanced than anything we currently have. It would have to be incredibly strong, like a deep-sea submersible, to withstand the pressure. It would also need a powerful cooling system to handle the intense heat, and it would have to be made of materials that wouldn't dissolve in the acidic atmosphere. It would be a monumental engineering challenge, far beyond our current capabilities. Interestingly, some scientists have proposed a different way to explore Venus, not on the ground, but in the sky. If you travel about 50 kilometers, around 30 miles, up into Venus's thick clouds, the conditions become surprisingly more manageable. At that altitude, the temperature is much cooler, ranging from 0 to 50 degrees Celsius, or 32 to 122 degrees Fahrenheit, which is similar to temperatures on Earth. The atmospheric pressure at that height is also very similar to Earth's sea level pressure. You would still need an oxygen mask to breathe and protection from the acid clouds, but the temperature and pressure would not be instantly lethal. This has led to some amazing ideas, like building floating cloud cities on Venus. Imagine scientific outposts or habitats held aloft by giant balloons or blimps drifting through the upper atmosphere. From these floating platforms, we could study the planet below using robotic probes. While it sounds like science fiction, it's based on real scientific principles. It's a creative solution to a very difficult problem. So while the surface remains out of reach, humanity might one day find a way to have a presence in the skies of Venus. It's an exciting prospect that shows how human ingenuity can tackle even the most extreme environments. Think about it.